Here is a view of the Trayer submersible vacuum fault interrupter. Two-way, one-way VFI protected, completely standalone with an internally mounted and fuse protected PT, SCADA ready. It comes with internally mounted CTs, auxiliary contacts, and outputs for SCADA controls. All of your outputs are through stainless steel, watertight bulkhead fittings, like such. It also comes equipped with a ground relay cutout switch. All stainless welded construction, hermetically sealed, typical of all of our submersible switchgear. With our VFI, we have a prismatic optical lens here with a yellow indicator for our trip indicator. Because identifying a tripped circuit is so critical for finding a fault in the field, our trip indicator is not electronic. It is an actual mechanical link directly to the fault interrupter mechanism. The unit is easily motor operated. It comes with the studs mounted on the roof for an easy retrofit of a motor operator. Now here, from the back side of the unit, you can see the fiber optic cord exiting the back of the control cabinet, and the box, the watertight stainless box that contains the fiber optic converter to an RS-232 port so that the field engineers can hook up their laptop computer up at grade level without having to climb down into the manhole. Here you can see that the fiber optic cord can be easily replaced in the field should it become damaged. And the fiber optic lines coming from the control cabinet pass through a watertight bulkhead fitting from the submersible control cabinet out into the gasketed connection area so that there's no chance of any water intrusion into the control cabinet or the high voltage compartment. Here's a view inside of the relay compartment of our submersible fault interrupter. Utilizing an SEL 551 microprocessor type relay in a draw-out panel for easy service. At Trayer, we prefer to use a commonly available relay system that most of your relay engineers have been trained on and are familiar with, as opposed to using proprietary electronics. We feel that this gives the owner of the equipment greater flexibility for service. You'll notice in this compartment that we have a 120 volt receptacle and a toggle switch that takes us from a test mode to an operational mode. What we've done here is we've created a system that allows the owner of the equipment to apply 120 volts AC shop power, put the equipment in a test mode so that you take the PT off the circuit and not backfeed your 600 amp bushings. And with that 120 volts, it allows him to power up the relay, do the relay settings, test the system, including a full trip function test right there in the yard before it goes out to the field for installation. This piece of equipment is also designed to be applied to 3 different system voltages. In this case, it's 12 kV, 17.2 kV, and 20.8 kV. This allows a customer to have one piece of equipment in their service yard that they can apply to all 3 types of distribution equipment that might be on their system. By going to the operational mode, you take this 120 volt receptacle off the circuit and go back onto the 120 volt auxiliary power that's delivered from the internally mounted and fuse protected PT.